What's up, everybody? Welcome back to another episode of the Beck Check podcast. On today's episode, I interview Dr. James Tanton. He has his PhD in mathematics from Princeton and currently works as a consultant who specializes in helping students and teachers learn the wonderful, joyous, and transcendental nature of mathematics. We spend most of the episode talking about this and the Quadrus Method for solving quadratic equations. We also have a brief discussion on the role of using AI in the mathematics classroom. Dr. Tanton is genuinely one of the most passionate and inspiring people to listen to about mathematics, and I know that I learn something new from him every time we interact. Let's jump in. Dr. Tanton, thank you so much for joining me on the podcast. You were like one of my mathematical superheroes. So it's really cool that I'm just really glad you agreed to do something like this.
Oh, I'm just a guy. Nothing special here. Just happen to like math and have thought about math for many, many decades. But thank you. It's very nice of you to say that.
All right, very good. So why don't you just go ahead, introduce yourself, tell us a little bit about how you got to where you are and just what you currently do.
Oh my goodness. Okay, so this could take up the entire podcast, my
Oh,
story. So let's see. Well, I happen to be sitting in Adelaide, Australia right now. I'm visiting family back home. So I grew up in Australia way back many, many decades ago. I'm an old guy now. So I went through my schooling here in Adelaide. And back in the 70s, it was a very traditional schooling. We were basically all sat in desks facing forward. Our teacher would basically lecture to us and give us worksheets to do. So our job was basically to memorize and do and repeat and do and just repeat and memorize and never actually ask questions. So I actually never liked mathematics in school, even though I was deemed very, very good at it. I was even labeled gifted at one point. I did not enjoy maths one bit because it seemed to me, that just memorizing formulas with no understanding where they came from and just answering 50 problems in a row, which had no context, meaning, or relevance to me. But I did it. I pleased my teachers, and I was very cognizant I was pleasing my teachers. So I actually went through my schooling in Australia. That's fine. Got my graduation done. And then I went to university. But I decided not to do mathematics in university because maths was just the most dreary subject ever. Until I happened to fall into a abstract algebra class in university. I was doing other work that led me to this. And abstract algebra is really a course about why does mathematics work the way it does? It's basically asking and answering all the questions I was wondering about as a kid. And I realized, oh my goodness, mathematicians do actually care about why things work the way they do. And they actually think that's the most interesting part of it. Calculation is secondary. Understanding why things work is actually the primary joy of mathematics. And I realized that's what I had been yearning for 12, 13 years of my schooling. No one showed me that that's what math actually is. And I fell in love with it. And I knew I was a mathematician. So I went all the way with math in uni. Got my undergraduate degree in mathematics. And then I kept going. I actually then moved to the United States in 1988 to get my PhD in mathematics. I went all the way. I got my PhD at Princeton, so went to that high-level research realm right off the bat. I fell in love with maths. I knew I was a mathematician. I went all the way with it. And so that's what led me to America some 35, 36 years ago, and I've been there ever since. Let's see. So I did what was expected of me. So I was just following my schooling path. So I got my PhD in math. So now as a professor of mathematics. So I did actually go into university teaching initially because that's what one's meant to do. Though I had a strong pull towards teaching and sharing the joy and the beauty and wonder of mathematics with everyone. So I decided to go and work in the liberal arts college environment. That's with a higher level of education that values teaching and research together. So it wasn't just like the pure research track I wanted to be on. I wanted to be on a career that focused on teaching as well. And that was lovely and fabulous. But then I also really had a heart-to-heart in my mind, thinking like, okay, I really did not know what maths was until about my 15th year of education, second year of university. And it really had made me angry that I couldn't see what maths was about. And that anger stuck with me all these years. And I thought about this. I really don't want any other person on this planet to have to wait 15 years to see what maths truly is. And most people never get to university maths like I did. I just happened to fall into it. It really has to be school mathematics that shows the joy and beauty of this wonderful subject. So I decided if I'm going to be honest about this and what pulled me to become a mathematician, and I want to share it with the rest of the world, I need to go to the arena of mathematics that people see and usually only see, namely school mathematics. So I decided to leave my university career and become a teacher. And I decided to become a high school teacher. And I chose high school because I thought that was the most challenging and, to be honest, joyless arena of maths education, because high school maths tends to be about the focus of getting kids into college and passing exams. The focus seems to be about exam passing. And I thought, okay, Where's the wiggle room for joy and human connection and relevance in that? So I decided to become a high school teacher to understand the system and to see where I could find and bring some joy into that system. So I did that for 10 years. And so now I'm this sort of strange creature that has a PhD in mathematics in Princeton, of all places. I've done basically close to 10 years of university teaching, close to 10 years of high school teaching. And for the past 10 years, I guess I've just been my own independent self as a consultant. Schools will write to me and say, hey, James, any chance you can come and talk to our teachers about making trigonometry exciting or quadratics interesting and relevant, or tells the story about why negative sum negative actually is positive. No one really seems to be able to explain that one. You help our teachers figure that out too. So it's been a real joy that this crazy career of mine, which I never really planned, actually has panned out to be a career where I really do get to talk to people all across the planet about letting mathematics be the joyful experience it truly is. So in a nutshell, that's my story. That's who I am. But that wasn't too long and long-winded, but there it is.
No, that's fantastic. And there's some similarities to your story with mine as well. I
Oh,
remember
cool.
I was labeled honors or gifted or whatever you wanted to call it. And I didn't even realize I liked math until I was taking my calculus class. And then we had all these different application problems where it came to physics. And all of a sudden I was
Aha.
like, wow, wait a minute. So this is why we do all this algebra. Like it finally started to click for me. But again, I feel that same pull or that same anger that you do is that so many people won't actually get to experience what math is because they're not going to reach that level for whatever
Which is
variety of
so
reasons it might be. But it's sad.
It's so curious. And we do all these things in the curriculum. It's like, do this now because you need to know it later on. Like your later on was the calculus class, my later on was university classes.
Mm-hmm.
But that's just not how the human brain works. You don't go learn stuff and read stuff because you might need to know it later on. You wait till later on when you learn it, when you actually need it, the context is there. Or you actually do the later on stuff now, bring the context back at the very beginning. But the school curriculum is not. It's all about all this, laid out path that's actually anti to the human experience of figuring out stuff you don't know you need to know until later on. The brain just does not work that way, and I fully concur. People should switch off from that. It's not right. It's not right. It's not fun. It's not meaningful. It's not relevant. It doesn't have connection. We need to turn that around. You and I, let's do it.
Let's do it. I really liked what you said because you wanted to kind of in a way go into the belly of the beast, right? Go into high school
Mhm.
mathematics. So I'm going to read one of your quotes here that I just really liked. I saw it on the Twitterverse one day, and I don't know who posted it, but this is what you said. Math is the beautiful, rich, joyful, playful, surprising, frustrating, humbling, and creative art that speaks to something transcendental. Kind of what you just said, most people would not describe high school mathematics in that way. So, how would you talk to the person who doesn't see math that way? How would you convince them to start seeing math as you describe it?
Oh my goodness. Okay, so I used a lot of adjectives there. So okay, let's
You
see if I can
did.
actually think of all of them. Like probably everything I could possibly think of, I guess, in that quote. Well, first of all, let's think about this. Mathematics has been around for thousands upon thousands of years. Humankind has been fascinated by mathematics for so long, and it cannot be because it's school mathematics. I
Mm,
cannot imagine humankind has been fascinated by doing worksheet after worksheet after worksheet. No one in the right mind wants to do that. No one enjoys just memorizing the quadratic formula and then doing 400 problems in a row on solving quadratic equations with the formula to be memorized. So
mm,
there's actually got to be more than maths than the school maths. That cannot have occupied humankind for literally tens of thousands of years. So what is that extra thing? Something is missing from our experience in the school world. Now, don't get me wrong, I've got to be very careful here. I truly, truly admire high school teachers. When I became a high school teacher, that was the hardest job I've ever had in my life. And I
mhm,
totally honor and admire that. It really is the system that gets in the way of true teaching, that really blocks that true joyful experience I know every teacher wants to bring to the community of students. It's really the administration, the bureaucracy, and the system that we have of assessment and continual assessment that stymies everything. So first of all, I just want to acknowledge that I'm not going to ever denigrate the high school teaching themselves. I think I'm in awe. So it really
mm,
is about the
mhm,
system I'm speaking of here. And the maths we experience in high school cannot be that transcendental maths I've been talking about in that quote. So there's got
mhm,
to be something more to it. Humankind is not fascinated by worksheets. So then the question is it about the real world application? So you were very much excited by the applications you saw of calculus when you first encountered math coming
mhm.
to life for you. And that's true. It could be about real world applications, but also there could be some more to maths that is just inherently joyful and awe-inspiring. I think I use those two adjectives there. So, it's like, well, not everything needs to have a practical application. Why do we read Shakespeare? I cannot think of a practical application of Shakespeare, of reading Shakespeare in my life, other than it represents a great, joyous human accomplishment, this body of work, that actually is really uplifting and mind-opening to read and examine, just for the human innate spirit of that joy and awe and wonder. It tells
Hmm.
you something about life and thinking. It doesn't have a practical application, that's fine, but it actually speaks to something that feels transcendental. Here's this author who's actually observed our human nature and put it into words and story. It is actually phenomenal that way. Mathematics does the same sort of thing. It's not the content per se, but it's the type of thinking it actually opens your mind to, that actually speaks to something beyond the individual. Silly little examples are really powerful ones. I mean, you might know that I am absolutely obsessed with dots. I love drawing pictures with lots of
Yes.
dots. And just think of this picture right now. So we can do this with purely talk about visual math without any visuals. But imagine a square array of 25 dots, 5 rows of 5 dots. So dot, 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 one row of five, another row of five, 5 rows of fives makes 25 dots. And if you just look at that picture and say, okay, well, that's not very exciting. That's a picture of 25 dots arranged in a square. But here's the beautiful thing about maths. It's all about shifting your perspective and just trying to find new ways to see things that are staring you in the face. For
Mm.
example, I could look at
Hmm.
that picture of 5 by 5 array of dots and say, you know what? I really think it's the sum of all the numbers from 1 plus 2 plus 3 plus 4 plus 5 and back down again, plus 4 plus 3 plus 2 plus 1. And if you can imagine in your mind, start looking diagonally. You've got one dot on a diagonal, shift down, you've got 2 dots on the next diagonal, then 3 dots on a diagonal, 4 dots on a diagonal, 5 dots on a diagonal, then 4, then 3, then 2, then 1. So that sum of all the numbers from 1 up to 5 and back down again actually is all 25 dots in that picture. The answer
Mm.
must be 25 to that sum. And you might say, well, that's not very exciting, James. You just looked at a picture and just looked at it a different way. But what I love about that, that speaks more than just that one concrete example, because I now know that the sum of all the numbers from 1 up to 10 and back down again has to be coming from a 10 by 10 picture of dots. It
Mm.
must equal all 100 dots in that picture. Or the sum of all the numbers from 1 up to 1,000 and back down again, which is more than my brain can handle. I just
Right.
know I could draw a picture of 1,000 by 1,000 array of dots and see the diagonals. I suddenly know, without a lick of arithmetic, the sum of all the numbers from 1 up to 1,000 and back down again just has to be a million, which is kind of getting mind blowing because I now
Mm.
realize that one little example was a portal to something that speaks to a fundamental truth about how arithmetic works. The sum of all the numbers from 1 up to whatever you want and back down again just has to be coming from a square picture of dots. You know the answer without doing any arithmetic. That feels powerful to me. I
Mm.
don't know what the practical application of that is, but it speaks to me. It says something is going on. Looking at very simple ideas in different ways can actually be a portal to deep thinking. And that's where I feel like math is transcendental. Like that was existing out there, waiting for me to discover that picture, to look at that picture just the right way. I mean, I've got this very Platonic view of mathematics. Math is out there, and we're observing it. When I
Right.
observe it, I feel like it's something beyond me. It's not just me as a human being. This is actually something that takes me beyond my own personal self and shows the power of mathematics. I can now add up all the numbers from 1 up to a million, back down again in half a second. In fact, I'll tell you the answers a million times a million. That's what is it in which country? That's quadrillion. No, trillion. Whatever it is.
Whatever
A
it
million
is.
million.
Yeah.
It used to be different countries in the US. A thousand million is called a thousand million. No, it's called a billion in the US, and they used to be called 1,000 million in Australia. And a
Hmm.
million was called a billion in Australia, which is called whatever it is in the US, trillion at that point. So I get very confused about US language versus Australian language. Forgive me still after all
No.
these years. But the point is, no matter what we call these numbers, we can see that beautiful math fact that seems to me beyond any one human. It seems to exist there out there. And that's why I say math is beautiful. I think that's beautiful. That's why I say math is playful, because I just played with a picture of dots. This is
Right.
why I say math is transcendental, because it leads to something that seems to be beyond just the immediate. And I love
Mm.
that. I adore that. I'm inspired by that.
Well, I'm inspired by what you just said. I really just enjoy listening to the way that you talk about math, the way that you describe it. And I also appreciate your comments about how we're in a system where there's certain curricular standards that we need to hit. There's certain
Mhm.
things that as teachers we feel like we are in a box and we just kind of have to make the most of what we have. And
Absolutely.
so I know lots of people know you for your exploding dots. The one area where I first found you was from the Quadrus Method. I remember I was teaching for Sunnyside Unified School District, and you came down and you did a PD and you led us through all the different levels. And my mind was just absolutely blown because I had never seen the visualization of that before. And so I feel like your work on quadratics is kind of your attempt to bring that awe, that wonder into a more curricular context of something that a teacher would be compelled to teach, right? So before we really jump into this Quadrus method, I'm kind of guessing at your motivation behind it, but what was your motivation behind creating your work on quadratics?
Okay, so let's see. So I did become a high school teacher, and the one thing I did notice is that the curriculum just seems so cluttered. And so I
Mm.
became a man on the mission just basically to remove the clutter and just say, what's the actual story going on here in this particular topic? In trigonometry, in quadratics, and logarithms, what's the story? What's the fundamental question that humans care about and cared about that made them want to even think about this stuff in the first place? And
Hmm.
what's the real thrust of what's going on? Also, I'm a very firm believer, this is going to sound very insulting, but the mathematics you need for everyday life, you're kind of done with by about grade 5, grade 6. If you really think about it, you
No,
don't
I
really need much of
agree. I
everyday
completely
life.
agree.
So then it says, okay, the majority of middle school maths and almost all of high school maths cannot be about the content anymore. I mean, you cannot predict that everyone's going to become a particular type of engineer that will one day need to know this particular type of mathematics.
Hmm.
No, it's got to be about using the content as a vehicle for teaching thinking. In which case, the content is actually kind of irrelevant. I've got nothing against any part of the high school content, as long as it's about teaching thinking. If it's not about teaching thinking, then I've got a lot to say about the high school curriculum. I say, get rid of it. No, use any topic like as a vehicle for teaching. And so that was my mission when I became a high school teacher. First, I want to really understand the cultural environment, all the demands on teachers, what all the obstacles are, and how to find the wiggle room nonetheless. Usually that wiggle room usually meant, okay, asking myself, how do I declutter this amount of content? Because the amount of content to get through is just ludicrous. And when the fundamental ideas about thinking are really just straightforward and about teaching someone to use their common sense. So, for example, when it came to quadratics, I asked myself, what's the actual fundamental story here about why
Mm,
humans care about this in some way? And what's the fundamental idea that basically just about use your common sense over and over and over again?
mm.
That's what I presented to you back in that time when I did that workshop down in Tucson. It's about what's the common sense way to do all of this. And suddenly everything just falls into place and becomes a non-issue when you're teaching thinking. Kids have fabulous brains, and I think we've trained them not to think they have fabulous brains in mathematics, but they do. So it really is about opening up their brains again to say, just step back, don't, and you can see your way through this. So you mentioned I gave you like different levels of quadratics, but that's exactly what it was. Just like I sort of kind of thin sliced it. So we'll start with
Right.
things that just seem like obvious, and then it was just like, oh, next little piece of obviousness, next little piece of obviousness, and before we know it, we're done. What was the big deal about quadratics? There's no big deal here. Other than that's just a joyful subject, and it teaches you how to think. I'm all for that.
Right. I've just started teaching through it this year for my second time using your different resources that you have online. And oh my
Mhm.
gosh, it's just been so much fun. Just starting with the area model for multiplication because that draws on their prior knowledge. It was funny, a lot of these
Totally.
students were saying, Mr. Beck, I already learned this in fourth grade. Why are we doing this right now? But the way I launched it kind of how you did as well when you talked about farming. And I made up this funny story about Farmer Beck and needing enough space for my cattle and what would the area be with these different dimensions. And I said, "Oh yeah, well, did you get a funny cow story last time you learned this?" And they said, "You know what? You got me there, Mr. Beck." So
Love it.
I've seen it, personally beneficial for me. And it seems like students really do who are very well accustomed to visual thinking and growing that different spatial awareness. I've seen definitely benefits there for students. I've seen students benefit from it from just the idea of perseverance, especially when it comes to deriving the quadratic formula, because that is a standard in high school that we kind of just, we don't want to do it. Like we see it for algebra one that they have to do this. And a lot of us are like, there's no way I'm going to
Mhm.
get all these kids to do all this algebra. Yet looking at it like what you just said, just saying one seemingly obvious thing after another, all of a sudden, boom, I had students deriving the quadratic formula last year, and it just was
Right.
so joyful to
Yeah,
experience.
they own it. It's theirs, and you don't need to teach per se. You're letting their brains open up, and they can actually do it beautifully and fine on their ownsies. Absolutely gorgeous. They now own the mathematics. Well done. Let's focus on the Quadrus method. We should explain what that is. So
Yes.
Quadrus is just the Latin word for square. So it's really, I'm just saying the square method here. So one of the great delights in the history of mathematics, people obviously wanted to, figure out puzzles, be they about farmers or counts of grain and so forth, but they didn't know what the number of beans in the bag was. They had some sort of algebraic relationship they knew had to be true. What must be the number in the bag? So people were trying to solve equations way from the get-go. Literally 4,000, 5,000 years ago, the Babylonians, Sumerians, who have some written examples of them trying to solve problems of that nature. And then throwing in these little tweaks of like, well, what if a number gets multiplied by itself in part of my equation? And they became a thorn. People did not know how to solve these things that had what we today called squared equations. And it's really, really interesting that we trained kids to say numbers like x squared and x cubed and never point out that even though we're in an algebra class, we've just said two geometry words, x
Mhm.
squared. Why do we call x times x squared? Because literally, that is the area of a square whose side length is unknown, happens to be x. So first of all, point out that we are very human in our way we think about and use our words in mathematics. We'd say x squared because we were literally thinking about squares. We say x cubed because we were literally thinking about cubes. A cube would be, x cubed would be the volume of an x by x by x cubed. And it's very interesting that we humans don't have a word for x to the fourth power. And you think,
Mm.
why? Well, because we humans don't know what the fourth dimension is, so we gave up. So it's kind of lovely to notice that actually we're very human in all of this. So then, okay, so we're now dealing with equations that involve x squared. So we're actually saying the word square. And I've been in geometry classes, I think, algebra classes, and I think my algebra class back in my day in Australia was we did this thing called completing the square. Well, think about what that literally says. You've got
Mm.
a square that's not actually complete, must have a bit missing, and you're filling in the bit. It's very geometry language. Yet I never saw a lick of geometry when I was doing quadratic equations in my day as a student, and also in the textbooks I was meant to be teaching from when I was a high school teacher. And it's absurd. We are using all this geometry language because people thought about this in a very geometric way. So let's literally complete the square. My way to handle that is, you've got a quadratic equation, let's just draw a square and let's see what parts are missing and use your common sense to fill in that piece, and everything becomes obvious. For example, a very simple equation might be that x squared equals 36. So some square has area 36. You just know right away, oh, that must have side length of 6. Great, you've just solved a quadratic equation. Now, of course, you have to be a little more careful here because we actually go a little bit beyond geometry. There is another arithmetic solution to that one, namely -6, because -6 times -6 comes to positive 36. So you can get the arithmetic solutions as well. But you got the geometry solution and you got the arithmetic solution. And then you say something like, well, okay, something squared was 36, piece of cake, I knew what to do. Well, now I'm going to make my something a little bit strange. What if I said x plus 5 all squared equals 36? Suddenly it looks very different on the piece of paper, but actually just step back. You're just saying something squared equals 36. My something better be 6 or -6. Oh, x plus 5 better be 6 or -6. That's it. Then I can work out what x is from that. That's all we're doing, using common sense, one step after another. And that's the Quadrus method, because I'm literally drawing a picture of square and saying, well, duh, what must the side length be? In the story,
Mhm.
there's nothing deep here. But we've cluttered the story curriculum of quadratics so much, you cannot see through it. We give names to all the different forms of equations. So your quadratic equations, we've got a standard form, vertex form, factored form. And I can think of many other ways to write a quadratic equation, and we don't give names to all those forms. I don't know what that means. I'm terrible with the jargon. The jargon gets in the way, yet we tend to focus on jargon rather than doing the obvious thing. We're talking about
Mm.
squares, I say draw a square. I'm very practical that way. In fact, that's what humans did, and they found that drawing squares was the key to unlocking everything. Well, those 5,000 years ago, and here we are, letting that all go and just making kids suffer in this purely algebraic, analytic way that has very little context, and it's more about the jargon than the doing. So that's the Quadrus method. This became known as the Quadrus method in medieval Europe because they're speaking Latin there, and hence we got the name quadratic equations. Which, by the way, actually, I should point that out. You should even question the name quadratic equations.
Mm.
We call an equation that just has an x term in it linear, because if you graph it, you get a line. We call equations that have an x squared term in it quadratic. which is weird because quad means four. Yeah, we're talking about x squareds. We
Hmm.
could call equations with x cubes and cubic equations. We call equations with x to the fourth of them quartic equations, which means four again. We call equations with x to the fifth of them quintic equations. So if kids actually think about it, or any adult thinks about this, we go linear, something about the number four, cubic, something about the number four again, the number five, the number six. It's weird until you
Yeah.
realize, of course, they're being called the quadrus equations because we're talking about quadrangles, four-sided shapes as the key to solving them. That's why they got the name. In fact, we even call it x squared. So hence the name, the square equations, or in Latin, the quadrus equations, which then became in English the quadratic equations. So just my point is, everything has a very natural human story and reason behind it for its names, for its choices, and yet the curriculum totally sidesteps all the humanness of the stuff and says, no, no, our job is to get you to solve this equation. And if we do that without thinking, I say just type it into Wolfram Alpha or just use ChatGPT. Your job is to get the equation, get the answer, and without thinking, then do it. Do what we have in the 21st century. Though ChatGPT, I would advise you to know, ask yourself, I believe the answer given to me? That's a lovely
Right.
exercise.
Yeah.
But yeah, so that's the story. So that's what I'm doing. Declutter the curriculum and return the natural human story to it. So if we could teach citizens of the 21st century to have the confidence to step back and use that common sense, oh, what a gift to the world that would be. And thank you, maths education. It could really do a spectacular job of teaching the world to be empowered thinkers.
Yes, absolutely. And what you're talking about, teaching thinking, that's what like you said, that's what this should all be about, right? Because I
Yes.
mean, like quite frankly, like when are they going to have to solve a quadratic equation in their real life? I don't know.
I don't really remember ever being in a grocery store and getting stuck before I could leave, having to solve a quadratic equation first. Never happened to
Right.
me.
Right. So we have to, like you said, we have to make it human. We have to make it joyful. We have to make it about the thinking. When I've had the chance to present a couple different times about the Quadrus method, kind of tied it into some building thinking classrooms principles.
Mhm.
The look on some teachers' faces when we get to where they get to see where the quadratic formula comes from, or the fact when they just said, "Oh, wait, this is what completing the square is we're literally completing a square." I'm just nodding and I say yes. Like
Yes.
it's there is this just this transcendental or this very like outside of ourselves moment that happens when we're working through all of these problems. And I just thank you that you put this out there so that we could access it and use it because it really has been beneficial for me.
It is absolutely beautiful, but also it tells you, sorry, it sounds a little sad, but we can go through our entire lives and not ask ourselves, what do the words I'm literally saying here, completing the square, literally mean? And realize, oh my goodness, I've never asked myself that fundamental question about the words I'm using. Let's turn that around. If a term in mathematics uses some words that seem curious, Google them. Just find out what they actually mean and say, well, hang on, why did humans use these words to go with this topic? And you'll realize there's something to it. There's actual meaning to everything we do. So completing the squares, the prime example, what's going on there? And yes, it is literally draw a picture of a square that has a piece missing and complete it.
Mm.
Mind-bending,
Oh,
fabulous.
fantastic. So, what else are you currently working on that you're excited about? I know that I've seen some of your posts about your college algebra book. Is that like you the main thing that you're working on now?
So yes, one of two things. So so my next little mission here is that I very much am saddened by what we do to kiddos that go to university, have struggled with maths in their high school career, maybe middle and high school career. They've made their way through, but they never really passed algebra. But they're in a university system where they have to do some sort of maths course. To do that, they need a prerequisite of some kind, and usually it is okay. I need like a pre-calculus type class. I can do my math requirement. And then for that, I actually need some college algebra. This course, college algebra, thing's only been around for the last 10, 15, 20 years. It's new in the university world, but basically it seems to be a repeat of high school algebra, but only louder and faster, which to
Yes.
me feels morally wrong. If it didn't work once or twice before for these poor thinking young students who obviously might have been going through high school algebra and realize there's a lot more going on behind the scenes that no one's telling me about. This is just random contextless, stuff thrown at me. There's no way I can memorize this. I don't blame them. And then we send them off to university and say, do it all again now, but faster. Do your 3 years worth of algebra in one semester. I think it's morally wrong and cruel. So I'm just trying to write up a set of notes about, okay, let's go through all this stuff. and in a way that's about the common sense logic behind it and why humans cared about this in the first place and how to think through it. And literally just think through it. Rely on your common sense. Once you know what the story is, common sense will lead you all the way through. So I'm going through that right now.
Mm,
I'm doing all of arithmetic because they often, have students do revisit arithmetic in
mhm,
base 10 and other systems and so forth. I'm in the middle on chapter on fractions. Fractions is a nightmare because it's just
mm,
a messy, contorted thing in the curriculum. And that's got me very much excited. So I'm really enjoying that. The other project I'm working on right now is kind of really interesting and curious, and I hope it really goes somewhere. But I was invited to join a particular young company called Synthesis School about a year ago to help them on a new AI type math tutoring system online. I
mm.
know it has lots of challenges and lots of like problems and all the rest, but they've got an approach that really was I found quite charming and appealing. So I said, okay, yeah, let's try this out. So I'm being their math advisor for them, trying to help them get off the ground and think about bringing interesting ways to do mathematics online that really is about the human connected story and feels like a human connected experience. And also get the math right. I know there's a lot of press out there about how current AI systems get the math terribly, terribly wrong. There's got to be some place in there that tries to get the math right as well. So that's a lovely experiment. So that's the other part of my life right now. That's the main part of my life, to be honest, right now. And I'm really enjoying that. And I hope it actually goes somewhere. And I think they've got a good shot at getting somewhere fabulous with it. But it's all at its beginning stages, but it's growing and it looks very hopeful. So yes, same theme, bring joyous, human, connected, meaningful, relevant mathematics to the world, be it through particular courses like college algebra or high school curriculum topics, or maybe on a level at scale with students being able to work online at home or in the classroom, maybe as a supplement of some kind. That's where I'm at right now.
That's fantastic. I am currently doing my master's program right now, a master's in math ed, and I'm
Hmm.
taking a class about technology, and we just had a little subunit on AI, about how we could use AI in the classroom, and it
Oh,
sparked quite a good debate
I bet.
with our discussion posts and really thinking through it. We used a variety of online programs. I don't think we used the one that you're working with, but
Hmm.
it was really interesting to play with. There was this one where there was something where I think it was solve some sort of log equation, and so I typed it in to solve the log equation. And you're right, like the tutor, it gave me some incorrect steps. So
Yes.
I mean, from like the teacher perspective, this is really interesting because I can analyze this. But from the student perspective, that's the last thing that we would want. We wouldn't want this tool that is meant to help students lead them in the wrong direction.
So that's why I think actually this is beautiful in the classroom because I would actually encourage kids to look at see what the tool is using right now. Say, do you believe the answer? And
Mm-hmm.
that would be a powerful lesson because it's about reading basically social media. Do you believe what's being said on the page? Because
Yep.
it could be wrong, and if the math is wrong, that's sort of a very obvious way to help bring that point back to the kiddos. That you can't believe everything said to you, even said with confidence and assertion, as most of the online programs say. They speak in a very adamant way, in clear way, as though they know they're right, giving that feeling they can be dead wrong. No, I had so much fun playing with various AI programs as well. I asked them to list for me all the triangular numbers up to 100. And he got it wrong. And I asked him, what's a triangular number? And he got the definition right and gave me some correct examples. Then I asked him to give me all the triangular numbers again and got it wrong. And I couldn't, and I said, your list is incorrect. 47 is not a triangular number. And so I'm so sorry. I made a mistake. It was impossible for it to get it to list some triangular numbers for me. I was
Mm-hmm.
having a very hard time with that.
Yeah, it's
But
really interesting. I think about the role of AI in education because on the one hand, I want to use it to make my job easier. And I know some people, I mean, technology can never fully replace humans. But there was
Mhm.
just this eeriness I felt when I was working with one of these programs where it could create a lesson for me. And yes, it needed some work, but it felt, I don't know, I was really struggling and wrestling with it where I was like, well, I don't want to lose who I am as a teacher. Like there's
Yeah.
something really real to me about creating my lesson to make it how I want. But on the other hand, there are certain aspects of AI that could make my life easier. So I don't know, I'm living in this tension. I don't know if you have any thoughts on that. We could probably do a whole nother podcast about AI and technology and everything, but I'm just really just considering these issues and how I could use it to help me and help my students, but I still want to retain like who I am as a teacher, if that makes any sense.
That makes total sense. And also, I have to say, I really do think mathematics is a human experience, and you are a human relating to humans. I'd be very sad if your beautiful humanist Elliot was ever removed from your teaching experience with kiddos, because it is a conversation between humans, and teaching is really should always be that way. I'm excited by these tools. I think they could do great things, but in the end, it's got to be us humans that are using the way that furthers our human relationship with our kiddos and theirs with us. So I'm with you. I don't want to ever see that go away. Um, and right now, we also have to go to the extra level. Like we have to make sure the math is actually correct. So first of all, do no harm. And right now, these programs are doing harm by being incorrect so often, which can be a lovely tool. As I mentioned, it's fun to play with these things with kids right now and say, well, how do we believe this answer is a lovely thing to do. It's also fun to do like I've done this with a couple of kids is here's the problem, you solve it, then type into whatever program AI program you want to use, get it solved, have it solve it, and then compare the two. Which do you like? Your answer, its answer? What did it do? Did it do things that surprised you? Did you do things it should learn from you? That's a nice meta conversation. And it also reinforces the point. Maths is not about getting answers, actually.
Right.
That's secondary to the story. It's really the process, as I keep saying, the thinking behind the answer, getting to the answers. That's the more interesting part. And I know people always say to me, but if you work for NASA, you have to get the answer right in order to get the rocket to be in the right spot. Well, that's true. Sometimes calculations truly matter. But you won't be the sole person making sure that, 17.594376 is the correct answer to 5 decimal places. You have a whole team of people checking and double checking and multi-checking. So you need to know how to get that answer. And yes, it will be checked, you bet, a billion times. You don't have to be the sole person getting the answer right. So it's not really about getting answers, especially in this day and age with calculators and technology to get answers. We can solve any equation in high school maths right now. That's not the point. It's got to be about the thinking. Which means, I should point this out, I was a very strange high school teacher. For example, I'd be given quizzes to give out to my students, or I'd make quizzes myself, and I'd often put the answers in the margins. You're viewing a tree of some height at an angle of elevation of 46 degrees, you're standing 100 feet away from the tree. How tall is the tree? And then I say the answer, 102 feet, and then a big blank space. Because I'm telling the kids, the answer itself is not the point. It's how do you get to that answer that's interesting, that matters, the thinking behind it. So I advise everyone listening to this podcast, try giving quizzes with all the numerical answers supplied in the margins, and then leave big blank spaces for the kids to fill in their work nonetheless.
Oh, it's so cool to hear all of your ideas and how much it overlaps with, obviously building thinking classrooms is like the biggest thing right now in math ed. But there's so many of your ideas just go hand in hand with that pedagogy that it's just really encouraging for me as a teacher who loves to learn new things, who loves to just try new things in the classroom to help students learn. It's just an encouragement for me to see a lot of the things that I've learned from people I look up to kind of mesh together.
Lovely. Beautiful.
Well, Dr. Tan, I really enjoyed this conversation, and I can't think of a better way to end it. Would you mind just sharing a little bit about how can people find more information about you, your website or social medias, things like that?
Oh, golly gee. Well, if you just type my name, I'm sure you'll find me everywhere. So it's James Tanton, Tanton. Let's see. So my websites are just messy. I'm not very well organized on these things, but the best website, a lot of my materials, in particular the Quadrus Method, if you're looking for that, would be g'daymath.com/courses. So GDAYMATH. So there's a little mix of Australian and American there. So it's G'day for hello, and math, the American version of maths. So g'daymath.com/courses. You'll see the Quadrus Method definitely there, as well as a few other things like exploding dots, which I think was mentioned today. And even the college algebra chapters, I've got them post up there. They're a little bit hidden, but if you poke around, you will find them. So I'm just an open book. I'm sharing literally everything as I write it. So you'll get all the drafts of everything. That's a good place to go. I'm definitely on X/Twitter. I don't know what my handle is, but I'm sure it involves the word Tanton. And you'll find me. And I'm on Facebook, and I am on LinkedIn too, but I tend not to look at LinkedIn. So you can write to me on LinkedIn, and I might not notice for a few months. But yeah, I'm on all these things. Good luck finding me. I'm out there. You'll find me. And YouTube, I've got tons and tons of stuff on YouTube. I think I've got some playlists and so forth that you can look at.
All right. Fantastic. Well, thank you again for being on the podcast. I really appreciate it.
My pleasure. Real joy. And thank you for all the incredible work you're doing and sharing the wonderful joy of mathematics across the nation and beyond. Thank you for that.